Ionic bonds. Transfer of electrons. Ionic bonds form when one atom donates an electron to another atom, creating oppositely charged ions. The attraction between the positive and negative ions holds them together. Common examples are sodium chloride, and magnesium oxide, Covalent bonds. Sharing of electrons. Covalent bonds occur when two atoms share electrons to fill their outer electron shells. This bond typically forms between nonmetals, as seen in molecules like water, HO, and carbon dioxide, CO. Formation mechanism. In ionic bonding, the electron transfer results in the formation of charged ions. In covalent bonding, the sharing of electron pairs enables both atoms to attain a stable configuration. Strength of bonds. Ionic bonds are usually stronger than covalent bonds due to the strong electrostatic attraction between oppositely charged ions. Covalent bonds can vary in strength depending on the number of shared electrons. Electrical conductivity. Ionic compounds conduct electricity when dissolved in water or melted because their ions are free to move. Covalent compounds generally do not conduct electricity, as they lack charged particles in solution. Physical state at room temperature. Ionic compounds typically exist as solids with high melting points due to strong electrostatic forces. Covalent compounds can exist as solids, liquids, or gases, depending on the molecular structure. Examples in nature. Ionic bonds are common in salts, like sodium chloride, while covalent bonds are found in organic compounds such as sugars, proteins, and DNA. Polar versus nonpolar bonds. Covalent bonds can be polar, uneven sharing of electrons, or nonpolar, even sharing. Ionic bonds, on the other hand, are inherently polar due to the complete transfer of electrons. Bonding elements. Ionic bonds typically form between metals and nonmetals, where metals lose electrons and nonmetals gain them. Covalent bonds occur between nonmetals, which share electrons to achieve stability. Overall difference. The key distinction lies in how electrons are handled. Ionic bonds involve electron transfer and formation of ions, while covalent bonds rely on the sharing of electrons to form stable molecules.